Hey, Calc BC, welcome back. Thanks for showing up. This is derivatives video number 2. Our first video focused in on the sort of basic rules, the addition rule, the constant multiple rule, difference rule, and of course the power rule. Today we're going to focus in on the more complicated rules of product rule, quotient rule, and chain rule. And what I will do is kind of remind you how those rules work through an example. I'm not going to prove them with the limit definition in the video because that just takes too long. If you are interested in how the limit definition can be used to prove all three of these, I'm happy to make another video for that. Maybe let me know in class, or put it down in the comment section. Smash that subscribe like button. No, I'm kidding. Don't do that. You can tell me in class, and I can either walk through it with you, or we can make another video to sort of show that. So let's take a look here. I've got the product rule all ready to go. And so just a reminder that with the product rule, you're going to have a function that is the product of two other functions. And what we're going to, we want to take the derivative. And of course, both those functions play a role in that rate of change. And how that slope or the rate of change is affected is through this product rule. So you can see that, obviously I have a continuous differentiable function, f of x and g of x, product of those two. And if I derive that function, h prime of x, I get the derivative of the first function, f prime, times the second function, plus the first function times the derivative of the second function. There you go. So if I do a quick example here for us, if I have h of x and I define that to be, I don't know. Let's do 2x squared times the sine of x, so that we can, have a nice product here of these two nice continuous functions. Polynomial functions, we love them. Continuous, differentiable everywhere. So 2x squared, definitely continuous and differentiable. And the sine wave is definitely continuous and differentiable everywhere. So using a little Leibniz notation, why not mix that in here? The derivative of h of x with respect to x. So the 2 is a constant. So I'm just going to kind of move that guy out of the way and then just focus in on the product rule for x squared and sine of x. And so since x squared is the first function, of course, I'm going to have 2x multiplied by sine of x plus x squared times the derivative of sine, which of course is cosine of x. And like all good calculus students, right, we're going to want to simplify this thing out as best we can. And really in this particular case, there's not a lot we can do. We could bring out maybe a 2x or an x and leave us at 2 sine of x plus x cosine of x. That's about as simplified as this bad boy is going to get. So without doing anything weird. We don't want to do anything weird anyway. So there you go. Product rule, quick and easy. The quotient rule, my least favorite of the derivative rules for sure, because we have that nasty denominator term, right? So I had to write it out like this because I was typing it out and the keyboard wouldn't let me do it. So I'm actually going to write it out in the handwriting here, just to remind us all, that f prime of x times g of x minus f of x times g prime of x. Okay, and we're divide that by g of x quantity squared. And whereas the product rule, it didn't really matter what order you went in. Quotient rule definitely matters. You have to f prime times g of x. Derivative of the numerator times the denominator has to be the first term because we're subtracting. And subtracting does not have, the commutative property, right? So for this one, let's just define h of x. And I don't know what we're going to have this time. Maybe we'll have our x squared guy back, and this time we'll divide by sine of x. Now this, of course, would have some restrictions on its domain. Anywhere where sine of x is 0, so any integer multiple of pi, that would be a problem. So x cannot equal n pi, or n is an integer. That's supposed to be that integer, there we go, integer. So that's a no-no. But that's okay because that would be in the denominator of the derivative anyway. So let's just run through that real quick. So the derivative, the numerator comes first, 2x sine of x minus x squared times the derivative of the bottom, cosine of x, all that over sine squared x. There we go. And there you go. There's your quotient rule. Okay. I think most of us remember the quotient rule and product rule pretty well. Last but not least, the one that always seems to trip people up is the chain rule. If Kat was here, she would be our person we'd call on right away for this, because as you remember, Kat enjoyed the chain rule oh so much. Important to remember that in this case, the function is basically layers. You've got an inner function and an outer function, or maybe you have multiple layers. And we sort of start by the outer layer and sort of peel them away by deriving each of the layers as we get further and further down into the function. So in this one, I'm going to define, hey, how about we have a pen and not that tool? I'm going to define h of x to be the sine of x squared. So if x squared is inside, now we have ourselves a chain rule problem. So the outer function, okay, is sine. So we're going to derive sine, and we're going to get cosine. But we're going to leave the inside function alone, and then we're going to multiply by the derivative of the inside function, 2x. So our final answer here, to write it like how we should, is 2x times cosine of x squared. And there's your chain rule example. So these three rules are going to come up quite a bit, and I wanted to just review them for you. I know they're pretty straightforward when we're dealing with basic polynomials, basic trig functions. Don't forget that the quotient rule is how we get the derivative of like tangent and cotangent and secant and cosecant. Without the quotient rule, we can't find those derivatives. So, all right, I think that's it for this video, guys. I don't think we need to belabor the point too much. I feel like this is all stuff that you got pretty good last year because we did it well before the COVID shutdown. So if you have more questions or any questions on this, be sure to ask in class. And I will see you guys Thursday in the afternoon session. So have a great day, everybody. Thanks so much for tuning into this video. I'm glad it was short. It's all you have to watch. But you can get started on your homework if you're so inclined. All right, everybody. Thanks a lot, and I'll see you in class. Bye.